Hello everyone, welcome to your YouTube channel, that is Civil Engineering Choice, and we have started the videos on the shear force and bending moment diagram. Already we have uploaded some videos on the standard cases to calculate the shear force and bending moment diagram, and these are the topics on which already we have uploaded the videos. That is like definition of beam, types of supports and corresponding reactions, sign convention, then definition of shear force and bending moment diagram, then different equations of equilibrium for a beam element. Then we have covered the video on the general steps to draw a shear force and bending moment diagram. Then few standard case also we have uploaded, like simply supported beam carrying a centrally point load, simply supported beam carrying eccentric point load, then simply supported beam carrying uniformly distributed load. Okay, and now today we are going to discuss about the simply supported beam carrying uniformly varying load W. Okay, so we will see how to calculate the support reaction, shear forces, and the bending moment of this particular case. Okay, means next case. So let's start with the direct fourth case, that is simply supported beam carrying uniformly varying load. Okay, simply supported beam carrying uniformly varying load. So why we are calling it either uniformly varying load? Because if we see the intensity of that UDL from A point to B point is gradually changes. Okay, it means the intensity, or we can say the magnitude of that W at A point is 0 and at B point is W. So we can say it's a maximum. So such type of load we called as a uniformly varying load. Maybe this uniformly varying load we can consider like this. Let's say this is simply supported beam. Okay, simply supported beam, and that point means A point having some magnitude of UDL, that is 10 kilonewton, and at this point means at B point, let's say it's a 20 kilonewton. It's a 20 kilonewton per meter, and this is also 10 kilonewton per meter. So the main thing is what, the load is not constant from initial point to final point of that particular load. That load generally called as a uniformly varying load. Maybe that load is 0 at A point and maximum at B point, or 0 at B point and maximum at A point. So it is uniformly varying. But now for our case, we have considered that intensity of that UVL is 0 at A point and maximum at B point, that is W kilonewton per meter. So while calculating support actions, we know that the first step to calculate the shear force and bending moment diagram is to calculate support reactions. So to calculate support reactions, first we have to convert that UVL to the imaginary point load. Okay, so whatever load for the point load we are considering over here, that point load is just a imaginary point load, means there will be no any effect on the shear force and bending moment diagram. Okay, so already we have discussed, if we see the simply supported beam carrying UDL and the simply supported carrying point load, so both loading conditions having the different effect of the shear force and bending moment diagram. Okay, so whatever load we are covering over here, that load is just a imaginary load, means it is just for the calculation. So how we can convert it? So while converting UVL to point load, we have to just take the area of that portion. Okay, now here we can see the intensity at A point is 0 and the intensity at B point is W, and the loading is as a triangular type. So formula for the triangle is what, 1/2 base into height. Okay, 1/2 base into height. So if you see over here, okay, if you see over here, the base is how much? Base is L. So 1/2 base is L and height is W. Okay, this height we can consider, this W we can consider as a height. So height is W. So whatever point load we are converting, that point load is 1/2, the point load is 1/2 WL. So we have written over here. Okay, that is 1/2 into WL UVL to point load. So this is the conversion of UVL to point load. So once you convert it, then we have to calculate the support reaction. Okay, once we convert it, then we have to calculate the support reaction. Let's say we have RA support reaction at A point and RB support reaction at B point. Okay, now once we consider the support reactions at a different point, the next step is what? Just apply the equilibrium conditions to calculate the support reaction. So the first equilibrium condition, already we have discussed it. We have three equilibrium conditions, that is summation fx is equals to 0, then summation fy is equals to 0, and summation ma is equals to 0. Okay, so out of these three equilibrium conditions, generally we are using first equilibrium condition, that is summation. We are ignoring this, we are ignoring this first equilibrium condition, that is summation fx equals to 0, and we are applying only one equilibrium condition, that is summation fy equals to 0 and summation ma is equals to 0, and out of that first we are applying summation ma equals to 0. So once you apply the summation ma equals to 0, it means what? Just we have to take the moment at A point. Okay, moment at A point of all the forces. Okay, and if you see over here, this is our Ra and this is our Rb reaction. So here we already converted that point load. Let's say this is point load is P. Okay, already we have converted. So there are two forces like P and Rb. So we have to take the moment of this P and Rb at the point A. And already we know that the moment is what? Moment is force into perpendicular distance. So if you take the moment of this P, the moment of this P is what? P, it is force, and the perpendicular distance of this P from A point, because we are taking the moment at A point. So we know the CG of triangle, whatever force we have converted, imaginary force we have converted, that force will act at a center of that triangular. Okay, and we know that if any right angle triangle is there, okay, for any right angle triangle, that CG is L by 3 from the right end, and another end it is 2L by 3. So the perpendicular distance of this imaginary point load which is acting at the center of the triangle, the distance is 2L by 3. Means the perpendicular distance of this imaginary force at A point is 2L by 3. So we can consider it is 2L by 3, P into 2L by 3. So this is the moment. Okay, this is the moment of this imaginary force. Okay, and if you see that moment is acting clockwise. Okay, moment is clockwise. And one more thing, for the support reaction we can use any sign convention. Means we can use clockwise bending moment positive or the anti-clockwise bending moment positive, but only one sign conventions we have to use to calculate the total support reaction. So now here we are using clockwise moment as a positive, and this imaginary point load will create the positive bending moment. That's why the P into 2L by 3 is a positive. Okay, that moment is positive. Now after that we can take the moment of Rb, correct? So Rb is the force. Again, moment is what? Force into perpendicular distance. Now Rb is the force, and the perpendicular distance of this Rb from A is L. So Rb into L, this is the moment of Rb force. And if you see the moment, that moment is anti-clockwise, so we can take it as a negative. Okay, so the moment at A point, okay, the moment at A point is what? 1 by 2 WL. So the P is what? 1 by 2 WL. Here we can see P is 1 by 2 WL into 2L by 3 minus RB into L. Now here we have to just solve this equation. Okay, now we have to just solve these equations. How we can solve it? So whatever RB into L term is there, we can take that term in one side. Let's say we can write it RB into L is equals to 1 by 2 WL into 2L by 3. We can write like this. So here we can see 2 get cancelled, okay, and 1 LL get cancelled. So the remaining term RB equals to W is remaining, L is remaining, and 3 is remaining. So WL by 3. So we can say that support reaction at B point is WL by 3. We will see it. Okay, just we have arranged it, and then RB equals to WL by 3. So this reaction we have calculated. Now once we calculate this reaction, now we have to apply the another equilibrium condition, that is summation Fy is equals to 0. Means sum of all vertical forces is equals to 0. And in this case, okay, in this case what we have to do? we have to apply the summation Fy means what? Sum that we have to apply the another equilibrium condition, that is summation Fy equals to 0, means sum of algebraic sum of all vertical forces is equals to 0. Now here Ra is a vertical reaction and Rb is also vertical reaction. So Ra and Rb both are positive, so we can upward, then we can consider Ra and Rb positive. But whatever W force we are considering over here, or the imaginary point load we have considered over here, that imaginary point load is downward. So we can consider this point load as a minus 1 by 2 WL is equals to 0. So this reaction we can consider, correct? So summation Fy equals to 0, that is Ra plus Rb minus 1 by 2 WL. Okay, now just solve it. So Ra plus WL by 3 minus WL by 2, because Rb already we have calculated, and that Rb is WL by 3 already we have calculated over here. Okay, now just solve it. That is Ra is equals to, what will be there? Equation WL by 2 minus WL by 3. Just we have taken that WL by 3 and WL by 2 on right side. So the sign will change, negative to positive and positive to negative. Now just take the WL as a common. The remaining term is 1 by 2 minus 1 by 3. So just solve this equation. We will get the final term that we required. Okay, that is W. If you take the WL as a common, so the remaining term is, let's say WL, the remaining, just take the cross multiplication, that is 3 minus 2 divided by multiplication between these two, that is 6. Okay, 3 minus 2 is 1, so remaining term is WL into 1 by 6, and we can consider that is WL by 6. It means the support reaction at A point is WL by 3. Now here we got the support reaction, means at A point it is WL by 6, and at B point it is WL by 3. Okay, once we calculate the support reaction, the next step is apply or use the second step, that is shear force calculation. Okay, shear force calculation. Now for the shear force calculations, what we have to do, we have to take the shear forces at each point which are available. Now here we can see in the diagram only two points are there, that is Ra and Rb. It means we have to calculate the support reaction, shear forces at A point and B point by considering the section on left of A point and on right of A point. It means first we have to take the section on left of A point and then focus on the left of that particular section, because we have started our calculation from left to right. That's why when we take the section, then we have to focus on the left part. And now here there will be no any force at A point on the left side. It means the shear force at A left is equals to 0. And one more important thing, that is we need to fix the sign convention, and already we have explain this how we have to consider the sign convention. Just consider the couple, okay, positive couple or positive, or we can say the clockwise couple, and then take a section between that couple. And if we focus on the left side, means let's say this is the section, and on the left side if force is upward, so that force we need to consider as a positive, and downward force negative. Okay, on the left of that particular section. So we have to consider that sign convention for the calculation. Okay, now here we have calculated the shear forces at A left. Similarly we have to take the section. Okay, similarly we have to take a section on right of A point and then focus on left of that particular section. And now here we can see only one force is there, or we can say the reaction is there, and that reaction is WL by 6. Okay, so the shear force A right, okay, the shear force A right will be only Ra and Ra reactions that we have calculated, WL by 6. Okay, once we calculate the shear force at A left, okay, A left, then we have to take the another point, that is directly B point, and if we focus on left of B point, okay, left of that particular section, then there are two forces. The first force is what? First force is Ra, and the second force is that UVL. Okay, whatever load we are considering over here. Now we have to consider the shear forces due to that UVL. Okay, so the first, okay, if you see on the left side of that section, okay, Ra is there, so we have written Ra. Okay, now after that whatever load is there, total load is covering up to the B point. We are taking section left to the B point. It means that the section is closely or nearly equals to B point, or we can say it is exactly at B point. Just we are focusing on the left part. So on left part total load is there, and the total load already we have converted in the point load, and that point load is 1 by 2 W into L. So same load we have taken over here. So RA already we have calculated, where RA is what? WL by 6. So just put the value of RA WL by 6, and another term is WL by 2. So just again same term, just take WL as a common. Remaining term is 1 by 6 minus 1 by 2. Okay, so for solving this particular bracket, we have to cross multiply it. Okay, so WL, so in cross multiplication, 2 into 1, that is 2, minus 6 into 1, that is 6, divided by multiplication of these two, that is 6 into 2, 12. Okay, so just solve this bracket. WL should be as it is, 2 minus 6, it is minus 4, divided by 12. Again we have to solve it. 4, okay, and 4 3s are 12. So we can consider WL into minus 1 by 3. So we can write this equation as like this, minus WL by 3. It means on the left of B, okay, on the left of B, the shear force is minus WL by 3. Once we calculate it, then next is what? Again we have to take the section on right of that B part, B point, and then focus on the left part. Okay, left part of that section. Now here we can see additionally we have RA, then this total UVL, and then additionally one force is there, that is WB. So total we need to consider for the calculation. Okay, so if you see over here, the B right is what? In B right there will be RA, then WL by 2, that is UVL, and then RB. So RA and RB both are positive because the direction of that forces are upward, and the UVL, the direction is downward, that's why it is negative. So RA already we have calculated, WL by 6, then WL by 2 as it is, and RB is WL by 3. Again here we have to take WL as a common. So remaining term is what? W1 by 6 minus 1 by 2 plus 1 by 3. Okay, so we can solve this equation. Okay, again we can take the cross multiplication, or another thing is we have to consider the LCM. Okay, so now if we see over here, 2 3, okay, so both equation, or 2 or 3, both from both value we can divide this 6. So we can take 6 as a LCM. So 6 into 1 1, then 2, or the 6 divided by 2, it is 3. Okay, 2 3s are 6. Similarly, plus 6 divided by 3, that is 2. Correct? 6 divided by 3, that is 2, or 3 2s are 6. So we can consider as a 2. So 1 plus 2, that is 3. Then 3 minus 3, it will be 0. So total equation will be 0. It means the shear force at B right is equals to 0. Okay, shear force at B right is equals to 0. So now here we have calculated the shear forces. Shear force at A point by taking section on left and right, and similarly shear force at B point by taking section left and right of that particular B point. So once we calculate it, the next step we can simply, okay, the next step we can simply draw the shear force diagram. So for drawing shear force diagram, first we have to consider this baseline, and after that baseline we have to draw it. So see, this is our A point, and at A left, okay, and A left there will be no any force, it is 0 in shear force, but at A right shear force is there, that is WL by 6. So we have to consider it WL by 6. Okay, now after that directly we have calculated the shear force at B point, and which is at left of B point. So that is again up to the B point, it is WL by 3. Here we can see the shear force at B left is minus WL by 3, so it should be below baseline. So it is WL by 3, and then after B right it is 0. So this is simple our shear force diagram for this case. Okay, once we calculate shear force, the next step is what? Just calculate the bending moment. Now for the calculation of bending moment, again we have to take the bending moment at each point, and here we can see only 2 points are there. The first point is A point, and second point is B point. It means we have to take the moment at A point and moment at B point. Okay, so the first moment at A point. So while taking moment A point, what we have to do? We have to consider the section exactly on the A point and then focus on the left, because in shear force calculations also we have taken the section and we have focused on the left part of that particular section. Similarly, in bending moment calculations also we have to consider the same procedure. So if you see, or if you take the section at A point and if you focus on the left of that A point, there will be no any force. So force is 0, it means the bending moment at A point is 0. Okay, bending moment at A point is 0. Now after that we have to take the bending moment at B point, and bending moment at B point. See how we have calculated the bending moment at B point. Okay, so we are taking the bending moment at B point, means we have to take the section at B point and then focus on left of B. Now here we can see two forces are there, that is RA and this UVL. Already we have converted that UVL in point load, imaginary point load, and that point load is W1 by 2 W into L, and the distance of that point load from the B point is the L by 3. Okay, it is L by 3. So we have to take the moment, or we are taking moment at B point. So first, moment of RA into perpendicular distance from the B point is L. So we have taken over here RA into L. Now after that, moment of this imaginary point load. So point load force is 1 by 2 WL and the perpendicular distance is L by 3. So this is L by 3. So here we can see WL by 2 into L by 3, and the moment of this is anticlockwise. And one more important thing, for the bending moment calculations at the each point we have to consider the sign convention. Okay, so in the sign conventions we have seen that if any sagging bending moment is there and if you take the section between that, the bending moment, okay, or the clockwise bending moment on the left of that section should be considered as a positive to the particular left of that particular section. So on that basis we have taken RA into L as a positive and WL by 2 into L by 3 is taken as a negative. Now just solve this. Okay, just solve this. RA already we have calculated. RA equals to what? WL by 6. So WL by 6 into L minus WL square by 6. So this term is what? WL into L, that is WL square by 6, and this is also WL square by 6. So here we can see WL square by 6 minus WL square by 6. The bending moment at B point is also 0. And if we see over here, bending moment at A point is 0 and bending moment at B point is 0. So at both point bending moment is 0. But if we see the shear force at this particular point, let's say this point is C. The shear force at C point is 0. It means the bending moment at this point is max. Okay, bending moment at this point should be max, and now we have to calculate that bending moment. Okay, so how to calculate it? Already we have explained in the last video. So how to calculate the zero shear point and how to calculate the bending moment where the shear force is 0. Okay, so just write the point to 0 shear calculation. It means we are calculating the position where the shear force is 0. So how we can calculate it? Just we have to take the section, okay, between that particular segment. Okay, segment means what? Now this shear force is 0 between A and B point. Okay, shear force is 0 between A and B point. It means we are considering that A, B as a one segment, and in that segment shear force is 0. That's why we have to take the section in that particular segment. And let's say whatever section we are considering, at that section our force is W dash, because we don't know exact magnitude at the section, because that load is linearly varying. Yes, if some value is there, so we can calculate it by using triangular theorem, or we can calculate it by using the interpolation formula. Okay, any one method we can use, but now here we are considering that magnitude or the intensity of load is W dash. Okay, and we are considering that section having distance x from the A point, and simple we have to take the shear force at this, let's say XX section, by considering left of that particular diagram. Okay, so how we can calculate it? Just see. Okay, so take a section axis, just we have explained it. Load at that particular section is W dash. Similar triangle theorem we can use, okay, to calculate the exact magnitude of W dash. So in similar triangle theorem, what we are considering? In similar triangle theorem, we are considering this is our one triangle. Okay, this is our one triangle, and another triangle is total triangle. Okay, so if you focus on this small triangle. So height of that small triangle is w dash and the length is x. So we have taken ratio w dash by x is equals to, now for whole triangle, okay, for this big triangle, okay, so for this big triangle the height is w and length is L. So we have considered W by L, but we are interested in W dash. So what will be the W dash? W dash is equals to Wx by L. So that is the magnitude at section. Okay, W dash equals to Wx by L. Now after that, just calculate the shear forces. Okay, so for the calculation of shear force, okay, for the calculation of shear force, and or we can say, we know the shear force is 0 at the x distance, that's why directly we can calculate the bending moment at that particular section. So mxx is equals to ra into x, because the perpendicular distance is x of that ra, so ra into x is the first moment, and then again whatever load we are considering, that load is UVL, triangular type UVL, so just convert in the imaginary. So imaginary again 1 by 2, base is x and height is w dash, and w dash already we have calculated wx by L. So the 1 by 2 x wx by L, and the distance of that imaginary point load from the section is x by 3. So this x by 3 we have considered. Just solve it. RA we have calculated WL by 6. So this is WL by 6 into x minus, just solve this, x and x, correct? So it is wx cube by 6. Okay, it should be x, it should be cube, it should be cube, wx cube by 6L. Okay, so this equation is WLX by 6 minus wx cube by 6L. Okay, let's say this is our first equation. Okay, so once you calculate the first equation, the next step is what? Just to find the distance. Okay, and to calculate the distance of that particular x, we have to differentiate that equation, because here we got the bending moment equation in the differential form, that is WLX by 6 minus wx cube by 6L. So to calculate the exact value of x, we have to differentiate that above equation with respect to x. And when we take the derivative, okay, when we take the derivative of that equation is derivative of WLX by 6 is only WL by 6, and the derivative of this WX cube by 6L is what? 3 WX square divided by 6L. Okay, means we have just taken derivative of x cube. The derivative of x cube is what? 3 into x square, and the remaining term, that is W divided by 6L, should be as it is. So the term is what? 3wx square divided by 6L is equals to 0. Okay, now just simplify this equation, and for simplifying this equation, we can consider one term on right side, that is WL by 6 is equals to wx square by 2. How that 2 is come? That is 3 divided by 6. Okay, that is 2. So once we calculate it, then just calculate the value of x. So how we can calculate the value of x? Take only x in one side and another term on right side, that is WL by 6 as it is, and if we take this term on the right side, it will be 2L divided by 6. So here we can see W will get cancelled. Okay, the remaining term is what? 2 and 3. The remaining term is L square by 6. Here we can see the remaining term is L square by 6, and if we take the square root, because we want the exact value of x, so if you take the square root, so the x is equals to what? L divided by under root 3. So this is our position of shear force, where the position of point where the shear force is 0. It means we can say that our shear force is 0 when x is equals to L by root 3 for this case. Now here we got the position, so directly we can calculate the bending moment at that particular point by putting x is equals to L divided by root 3 in the first equation. Okay, so the maximum bending moment is, just put this value, okay, in first equation. So the first equation is what? Bending moment max equals to WLX divided by 6 minus WX cube by 6EL. So X is what? X is L divided by root 3. So just put that value WL by 6 as it is, where X is L by root 3 minus, here also we can see W divided by 6L as it is, and X cube means L divided by root 3 whole cube. So just solve it. Okay. So once we solve it, WL square by 6 under root 3 minus, here also WL square divided by 6 into 3 under root 3, because LL get cancelled. Here we can see, if we solve these equations, what will be there? WL cube divided by 6 under root 3 into L, 1L, and there 1L will get cancelled. Remaining term is WL square by 6 under root 3 that we have written over here. Okay, इसका भी cube होगा, so it is 3. So we can say 6 into 3 under root 3. Okay, so now from this equation, okay, from this equation, just we have to take the common term out of that bracket and this cross multiply it. Okay, so already we have discussed how to cross multiply this. So after cross multiplication, this term in this bracket will be 2 by 3. So just solve it, we will get the maximum bending moment value is WL square divided by 9 root 3. So this is our maximum bending moment. See, already we have calculated the bending moment at A point, that is 0, bending moment at B point is 0, and now the maximum bending moment is WL square divided by 9 root 3. This is at where the shear force is 0, okay, and it is positive, and it is positive. So we will see bending moment diagram for this case. Okay, so this is our bending moment diagram. Okay, so this is our bending moment diagram. See, the bending moment at A point, bending moment at A point is 0, bending moment at B point is 0, and the bending moment at point where shear force is 0, it is maximum, that is WL square by 9 root 3. Okay, so this is the simple steps to calculate the shear force, bending moment, or we can say the support reaction of uniformly varying load. Okay, and one more thing, this is not a one case for the uniformly varying load. Another case are also there. Let's say suppose this is simply supported beam. Okay, as we discussed at the starting of our session. Okay, let's say this is also one of the case. At A point we can consider W1 is the magnitude, and B point W2 is the magnitude. This is the first case. Second case we can consider simply supported beam again. Okay, now at A point load is maximum and at B point load is minimum. Here you can see W1 and W2. This is also one of the case. And the fourth case is at A point magnitude is maximum and at B point it is 0, so it is W. So this is our first case. This we can say as the second case. Okay, then third case and the fourth case. Okay, these are the possibilities of uniformly varying load. Okay, so if you want the bending moment and the shear force diagram on this case, means 3 and 4 case, or let's say second case also, so please comment in the comment box as a case 3 and case 4. If you comment or if you write the case 3 and case 4 in the comment box, so I will definitely upload the video on these two cases for the shear force and bending moment diagram. Okay, so next time we will see the next case, that is simply supported beam carrying movement. Okay, here already we have taken. Okay, in next video we will discuss this. So thank you so much. If really you are like this video and if you are getting some knowledge from this video, so please subscribe my channel and share this video to your friend, so he will get the benefit from this video. And as I'm planning to upload the videos on the all structural subjects like engineering mechanics, strength of material that we have started, then structural analysis, then structural design, okay, means reinforced concrete design, then steel structure design, and the precise concrete design. Also I am planning to upload some videos which are important to do the work in the industry. Okay, so please like, subscribe and share this video to your friend to get the benefit and to motivate